Today we are discussing about chapter number 5, law of motions. In this chapter we will discussing about that there are some topics are there. See here, the law of motions. There are the first Newton first law, second is that force, third one is that mass, Newton second law, and also Newton third law. Then after our examples and also exercise of this. But now first of all, what is that the Isaac Newtons are there? Isaac Newton's work represent one of the greatest contributions to the science ever made by the individuals. So this is the Sir Isaac Newton's. Okay, so they give the greatest contributions to the science. So see, this is now first of all describe the dynamic. So dynamic is describe the relationship between the motions of object in our everyday world and the force acting on them. Okay, now language of the dynamics are that. So first of all, what is that? The force. The force is measure of the interactions between two object. It is a vector quantity. It has a magnitude and the directions. And the second thing is that the mass, the measure of how difficult it is to change object velocity. Okay, so see here the force. The force is the measure of the interaction between two object, pull or push. So see first the first figure is shows that the pull or push. If we are stretching in this side, it is a pull, and we have press in these directions, it is a push. So there are the pull and push directions. Push is that, and there the another is that. So vector quantity has a magnitude and the directions are there. Now maybe contact force or a field force. See here the contact force, there are the two force are there. Contact force and the field force. So due to the magnetic force, this is a field force, and electric force due to this is the electric force. It is also a field force. Okay, so contact force result from physical contact between two objects, and field force between the disconnected object are also known as the action at a distance, are also called the action at distance. Now see here we are discussing that the gravitational force, Archimedes force, also is that what is that, the friction force, tension force, spring force, and also the normal forces are there. So vector force and vector nature of the force, vector nature of force, vector as a the magnitude and the directions. Net force in a resultant force acting on object is that F it is equals to net is equals to summation of F, it is equals to F1 plus F2 plus F3 up to Fn. So you must use the rules of the vector additions to obtain the net force on F on an object. So see here the mode, there are the there are the two forces are there, F1 and F2. Okay, two different things are there, and suppose and whenever we are applying the two forces on the same things on that time, F1 and F2 is see here on that time. So the bar force is the magnitude of this force is known as that the F1, it is equals to the F1 plus F2 square. F1 vector of F1 it is equals to F1 plus F2 square. On that time, what is the theta? So theta is made up of this in these directions. Okay, so one force is in this direction and one force in this direction. So resultant force is in this direction. So F is equals to some F1 square plus F2 square, it is equals to 2.24 newtons are there. So theta is equals to tan inverse F1 by F2, it is equals to minus 26.6 degree are there. So it is the angle between on that 68 60 26.6 degree is that our angles. Now see here Newton first laws are there. So what will happen when an object is rest tends to stay at the rest, and object in motion tends to stay in motion with the same speed and in the same directions unless act upon by a unbalanced force. So see here in this figure, what will happen? Object remain rest as long as net force act on it. The object moving with the constant velocity continues to move with the same speed and in the same directions. The same velocity as long as no net force act on it. So keep on doing what it is doing. Okay, suppose there are this car is in the moving on that direction. There are the nothing is there. This wall is not in, is there. So it is moving in this moving directions. But there are the some forces are there. So okay, so that's why it will what will happen. See here in this figure. So in this GIF, so it is a shows us. So now see here the Newton first law. The object is rest tends to stay at rest and object is motion tends to motion. It means whenever it is something is the going on that time it is a in the going it's in the same directions. And suppose something is in the directions, so on that time what will be there? There will be a in the in, going to in the motions on that time it will be motions due whenever not we are not ignoring the any kind of force. Now see here when force are balanced the accelerations of the object is zero, so object at the rest v is equals to 0 and 8 is equals to 0. Now object in a motion, so v is not equals to 0 and on that time 8 is not equals to 0. So the net force is defined as the vector sum of all the external force exerts on the object. If the net force is 0, the force are balanced. When force are balanced, the object can be stationary or move with the constant velocity. So see here, now mass and the inertia. So every object is continuous. It is in its state of the rest or a uniform motions in a straight line unless it is a compelled to the chain that stay by the unbalanced force impressed upon it. Okay, so what is that? The every object is continuous in state of the rest or uniform motions in a straight line unless it is a compelled complete to the chain that state by unbalanced force impressed upon it. So if you are sitting on that any bench, so there are the benches in a steady condition and also you are in steady condition. But suppose the bell will be ring on that time on with recess will be recess bell will be rings. So on that time what you will do, you are going to the outside, trying to going to the outside. So on that time you are in the sitting. Why? Because the force are there. Why? Who is the force? The sir was that there. Okay, so this is the force are there. So it is a in the stay conditions are there. Okay, and when the recess will be done, on that time you will be going to trying to going to the outside. So there are the two situations are there. So mass is measure of the amount of inertia. Mass is measure the resistance of object to change in the velocity. Mass in an inherent property of an object. Now scalar quantity, and it is a scalar quantity and its SI unit is kilograms. So see here, now the Newton second law are there. So accelerations of object is directly proportional to the net force acting on it and inversely proportional to the its mass. So see here, the F is equals to summation m into a. So F net is equals to 8 is equals to F by m. So these forces gives us these are our accelerations. Okay, and also the what is that the force acting on it and inversely proportional to the mass. So this see here, this is inversely proportional to the mass. So see here, F it is equals to ma. Okay, F it is equals to ma. So the net force is that mass into the accelerations are there. So unit force of that the second Newton second law is that F it is equals to F it is equals to m into a. So the SI unit of the force in is a Newton, and in one and Newton is equals to 1 kilogram into meter per second square. So it is gives us the 1 Newton's value. So US customary unit of force is found, so it is equals to 1, it is known as the L into B. So 1 Newton is equals to 0.25 L into LB. So weight also be measured in the LBS in the force equals to mass into acceleration. So what is the acceleration in that case? So see here more about the see in this figure there are the different kind of force are there, but all the four trying to go in this size. So more about Newton's second law, you must be certain about which body we are applying it is to for it to. So F net must be the vector sum of all the force that act on that body. So only force that act on the body are to be included in the vector sums. So net force component along an axis gives rise to the acceleration. So along that same axis is that F net is equals to F into ma x. And suppose in the y directions on that time F net y is equals to m into a y directions are there. So guys, thank you so much. Today we are discussing this much only. After that we will discussing about the gravitational force and the third law. So it is an introduction portions. After that we will starting from this our book.